credit. No, you don't have to work, you don't get credit. You just have an answer down when it's wrong, you can pull the credit. So make sure you have some work down so that I can see what you did. And clearly mark all the answers. And the one thing I hate to do, particularly on a final exam, is, you know, to run a Where's Waldo looking for the answer. Okay, you know, just make sure it's there and it's visible and I can see it, that it's marked, something like that. You'll be in good shape. Okay, number one, pH of seawater is 8.1. My pH is 8.1. Put that down. Your pH. What it wants is the pOH, concentration of the H3O plus, concentration of the OH negative. Once you see a problem like this, a really easy problem to do if you know how to manipulate your calculator. If you know how to work your calculator, it's very simple. Because if we're going to look, the pOH in this case, if you're given a pH rather, the pOH is going to be 14 minus the pH. The hydronium ion concentration will be 10 to the negative pH, and the hydroxide ion concentration will be 10 to the negative pOH. So it's just a matter of a couple of buttons to push on the calculator. Okay, the first one, we're going to take 14, and we're going to subtract 8.1 from that, and that gives us a pOH of 5.9. That would be your first answer, 5.9. Now, this is going to equal 10 to the negative 8.1 power. So what we do to get that is shift log negative 8.1, and you come out with 7.94 times 10 to the negative 9. And you put an M after it because it's asking you for concentration. Molar. Okay? Second one, that what you got?
Yes.
Okay, good. The second one is going to be, or the last one rather, is going to be 10 to the negative 5.9. Okay, so again, shift log negative 5.9, and I get 1.26 times 10 to the negative 6, and because it's concentration, and there you go. Okay? All right. If you have questions, stop me as I'm going through this and we'll get them straightened out. Now the next one, we want to know what is the conjugate acid for each of the following substances. To figure out the conjugate acid, you're going to take the material, OH negative for instance, and you're going to add a hydrogen. You're going to add H plus to it. And you're going to get your acid, which is H2O, or HOH, either one would be accepted. Okay. Second one, HCO3 negative. I'm going to add an H plus to it. Going to give me H2CO3. Positive and negative cancel out, so that's why you have no charge on the last substance. Third one, HSO4, negative. I'm going to add an H plus to that, and that's going to give me H2SO4. And the last one is NH3. So if we take NH3, and we add an H plus to that, we're going to get NH4 with a plus charge, or HNH3 will be acceptable as well. Okay? If it asks for conjugate base, you're going to subtract the H plus. All right, number 3 gives us a KB. A KB of 4.4 times 10 to the negative 4. That's what we're given. We want to find Ka. All right, on the formula sheet, does it give it to you? No. Okay, it doesn't give it to you. So this is one of those things you just have to more or less remember. And Ka times Kb equals Kw. Well, what do we have here? We've got a Kb. So we're going to look for Ka. Ka times 4.4 times 10 to the negative 4 equals Kw. We should know what Kw is. And Kw is 1 times 10 to the negative 14. If you don't remember that, it's on the charts. Just look for equilibrium constants, it's going to be there. Ka then will equal 1 times 10 to the negative 14 divided by 4.4 times 10 to the negative 4. So we're going to take 1 exponent negative 14, divide that by 4.4, exponent negative 4, and I come out with about 2.27. Times 10 to the negative 11, there's your answer. Yep. Excuse me? There are charts, it's available on the reference tables, or it's just something you can remember. Kw was always 1 times 10 to the negative 14. Okay. Now the next one you can't really figure out, but work your way through it with me. And the reason you can't figure it out is because I didn't give you concentration of the acid. So what I did was on the exam I said it was 0.1 molar. Okay, so what we have is benzoic acid, C6H5COOH, and we have a 0.1 molar solution. Okay? I threw in the concentration. The pH is 2.44. Right, and my question is, what's the Ka? Well, first thing we have to do is we have to write an acid equation. So the acid equation is going to be the C6H5COOH. I'm going to add water to that. Equilibrium system is going to give us H3O plus and C6H5COO negative. The benzoic acid, since it's an acid, gives up the hydrogen. They know how to write these equations. Then, we're going to make it a nice problem. Okay. Our initial concentrations would